Hey everyone, welcome back to my YouTube channel where we learn to be a better programmer. And in this video, we're going to talk about abstract classes. So before we get started, be sure to hit that subscribe button and turn on post notifications so you don't miss out on the future videos. Abstract classes fall under the umbrella of object-oriented programming. They allow us to share functionality across subclasses. Okay, so think of an abstract class as this top-level class that has attributes common to all of its subclasses. Okay, so an abstract class is the parent, and the subclasses are the children. Okay, so I'm going to create a new Java class called AbstractChessPiece. And then at the beginning of this, I'm going to actually say public abstract class AbstractChessPiece. Okay, so the abstract reserved word basically says that the AbstractChessPiece class cannot be instantiated. Okay, so I'm just going to create two fields. I'm going to say private string name because every chess piece has a name, and then I'm going to say private string color because every chess piece has a color. And then I'm going to generate the constructor for both of these, and then I'm also going to generate the toString for this as well. Okay, now I'm also going to generate a main class, and then inside of this main class I'm just going to say main, and then if I tried to instantiate that AbstractChessPiece class, I'm going to say AbstractChessPiece class piece is equal to new AbstractChessPiece, and I tried to do this, it's going to give me an error. Right? It gives me this weird syntax as well because it's looking for an implementation of AbstractChessPiece. Okay, so instead, what I can do is I'm going to create a new Java class called pawn. Okay, so a pawn is going to extend an AbstractChessPiece. Okay, so the extends keyword is how we inherit from another class. Okay, and it's giving me this red squiggly because there's no default constructor for AbstractChessPiece. So it's basically saying create a constructor matching the superclass. Okay, so basically, if we want to create an AbstractChessPiece, we need to basically fill in the superclass's constructor to ensure that we've adhered to that superclass's template. Okay, so we provided a constructor called AbstractChessPiece that takes a string for a name and a string and a color. Every subclass needs to call the super constructor for that AbstractChessPiece. So we don't need to actually take in the string name as a parameter into the pawn's constructor. We could just say pawn and pass that into the super constructor, and that is completely valid. So if I go to my main method here and I say AbstractChessPiece piece is equal to new pawn, and I just say color is blue, just as an example, and then I say system.out.println piece.toString, and I run this, and we see that the AbstractChessPiece its name is a pawn, and the color is blue. Okay, so but also what's valid is I can just say pawn directly. Okay, so what I'm going to do now is I'm going to create another class called bishop, or I'm going to call it rook, and then inside of rook I'm just going to say extends AbstractChessPiece, and then I'm going to create a constructor, and then I also don't need that string name again because I can just pass in rook directly. So whenever I create a rook with a color, it's just automatically going to set the superclass's field name to rook. Okay, so if I add rook is equal to new rook, and I call it red, and then I basically copy this line and say rook.toString and run it, we see that the AbstractChessPiece is the type, and then it's a pawn that's blue and a rook that's red. Okay, so that's kind of how we're able to encapsulate information, shared information in an abstract class and share it across all of the subclasses. So something also pretty neat that you can do is you can say public static void print classes, and then I can take an AbstractChessPiece as a function parameter and say piece, and then I can just say system.out.println piece.toString. All right, so then I can get rid of these, and then I can just say print main.print classes of piece, and then main.print classes of rook. Okay, and then I run this, and we get the same output. Okay, so that's an important side effect as well. It's like wherever we use an abstract piece, we can pass in any subclass of abstract piece directly. So also, this is valid. If I say abstract chess piece and then just abstract chess piece directly, this still works as well. Okay, so abstract classes are extremely useful to share common functionality and attributes across many different subclasses. Okay, but it's limiting because you can only, in Java, you can only extend from one superclass. So I can't say rook extends abstract piece and extends pawn, right? This is not valid. So how do we say for example, right, in chess, like the queen is the combination of the rook moving and the bishop moving. Okay, so we can compose the rook and the bishop together, and that's a concept called composition. We're going to talk about that in the next video. Okay, so that's all I want to talk about abstract classes. They're very useful for sharing attributes and functionality across different subclasses, but they're also limiting in the context of Java because you can't inherit from multiple classes. Okay, so if you like the video, please hit that like button and subscribe so that you don't miss out on the next video. All right, thanks.